Okay, just listen, and if you take a look at these values, if you really try and draw a scatter plot, all right, if you really try and sketch a scatter plot, you will get this. And when you will get something like this. Okay? Yeah, no question, no question. This is not any question. Now, shall we take a look? Clearly, if you take a look at a scatter plot without even trying to sketch, calculate R, there is no linear correlation. R is almost 0 all over the shop. You see 1, 2, 3, 4, 5 all over the shop. But you would realize by now that you should be able to spot that actually there is some correlation. Quadratic. Very good, quadratic. Now, how strong is this quadratic correlation? Is there an R? Almost perfect, very good. What is the R? Are we able to calculate the R? How close is it to a quadratic curve? Using the ideas that we have used for linear correlation. I think we can. How? We just need to create one column called x squared. 9, 1, 0, 4, 60. And if we plot y on x squared, you will realize that you will get 0, 0, 0, you will get 1, 1, you will get 4, 3.8, somewhere here, you will get 9, 8.5, and you get 16, 16.5. You will almost get a perfect straight line. Do you follow what I'm trying to say? So this technique, so what we are trying to say now is, now actually x squared and y are linearly correlated. X squared and y are linearly correlated. Okay? What do we try to... So this is a technique. So if you suspect that two variables are related in a non-linear way, we transform it to a linear relationship. Okay? That is the technique we use. So if we can say, oh, x squared and y, there is an R, we can calculate R already. And it's almost 1 if you take a look. Do you follow? Okay? So let's go on to our example 11. Transformation of non-linear data points to linear ones. Look, the company believes that this is the relationship. Is this linear relationship of x and y? Not linear. Not linear. All we need to do is to transform, do some manipulation to find which variable and which variable are linearly correlated. Okay? So, the question asks, tell you, using the transformation involving big Y equals log Y. So, give a sketch for the data as shown on your GC to illustrate the relationship is a reasonable one. Okay? So this one is all given. Alright? So this is what you do. Log Y. Okay, you just use your GC to calculate, no big deal. This one is given. And your X. Then you do a scatter plot. Okay? Not bad. There is a, it shows that it's almost, the points almost lie on a straight line. Hence, log Y and X are linearly correlated. Almost linearly correlated. Use, or rather find, the estimates for A, B, big A and big B. Now, how do we do it? If you take a look at the initial relationship, your suspicion, y equals a, b, x. You will do some manipulation. If you take log on both sides and you apply laws of logarithm, this is what you get. If you use laws of logarithm and after you take log on both sides, this is what you get. So this is the form. I don't know whether you recall your O levels. This is of the form big Y equals to C plus M big X. Correct? Y equals to mx plus C. And you have already done this bit. Yes? And it's possible for you to find the regression line. This one is from GC, no big deal. Okay? Before that, sorry, let me do this first. Okay? So, look, from here, since log y, and when you plot log y and x, approximately lie on a straight line, the model seems reasonable. This is answering the first part. Okay, this is really answering the first part. If you plot log y, this column, and x lie on a straight line, this model seems reasonable. Because log y against x seems like a straight line. Then with these data and these data, you should be able to find the regression line of log y on x. Okay? Now when you do this kind of regression line, you don't really have to enter all this, you know. If you make this L1, make this L2, this one can be L3, where L3 equals to log L2. Do you follow? Okay, when you edit list, this one can be L1, this one can be L2, this one can be log L2. Then when you find regression line, you just, the X list is L1, your Y list is L3. Okay? So you don't have to enter all these long decimal places. Alright, so then you should be able to find the regression line of y on x, big Y. Big Y essentially means log y, okay? Is this. Note this is big Y. Okay? Note this is big Y, not the small y that we have. This is actually log small y. Then we compare. Look, you compare this and this. We should be able to find what is big A, what is small. What is big A, what is big B. Okay? What is the estimate of A? What is the estimate of A? Which is, sorry, this one must be log. Okay, log A is actually 0.781. Okay, log B is actually 0.327. Okay, can? Okay, this one you have to recall your O-level knowledge of transformation, your big X, big Y. Okay, can? Next, the question asks us to predict the sales in year 7 and year 12. Okay, let's take a look. I think the scatter plot tells us gives us a good idea. You have found the sales of year 1, year 2, year 3, year 4, year 5, year 6. Now they ask us to predict year 7. What is the sales? Reasonable or not reasonable? Not very sure. Not reasonable, say some. Just now the example, remember the height example, 266 cm? That was anticipating what? 40 years when your data collected was only 6.6 to 13.5. Now you have collected data from 1 to 6 and you just want to predict 7. I think it is reasonable. I don't think you cannot say that it's super accurate, but I think you can say that it is reasonable. So before that, we do the calculations first. When x is 7, y is this. How do you get that? You just substitute this into your linear regression line. If big Y is 3.07, then Y is 10 to the power of this. You will get that. Okay? No big deal. Now this estimate of 1178, this sales of 1178 is not too bad. Firstly, the number is not ridiculous compared to year 1 to year 6. Secondly, it is only 1 year after year 6. So, oh sorry, let's not do this first. Okay, never mind, we can calculate. Sorry, we calculate these two first. We substitute 12 in, we will get a y. Okay, no big deal. This is just calculation. This is quite easy. Okay, I just said no big deal, says Zhen Ting. I shouldn't say no big deal so many times. No big deal. Okay? Now, as I said just now, yes, you collected data from 1 to 6. The prediction for 7 is acceptable because you only have 1 year difference. It's only 1 year after that. Okay? Okay? If x is equals to 12 later, then you will know the answer lah. Am I right? Okay? Then some of you will start to question, what if it's 8, year 8, how? Okay, now this one, that's why stats is so fun, right? Really, there's no magic answer, right? Are you prepared to say, hey, 2 years I use this same regression line? Are you prepared to? Look, this answer is not really the answer. What we are saying is this, okay, we are prepared to say, okay, we accept some error, never mind, but okay, 1 year after that, we can roughly use the same regression line. It's not perfect. So when you ask, year 8, how? No perfect answer. If you are prepared to accept the error that is possible, yes, you use. But if you go up to x equals to 12, looking at the numbers, which is 50,000, compared to the data that you see is only in hundreds, it seems ridiculous for the sales to increase by 100-folds within 5 years, 6 years. Really ridiculous. You know what I'm saying? Because you look at the number 50,000, then your year 1 to year 6, the maximum is only what? Only 560 maximum. So it's really 100 times ridiculous. So this one really ridiculous. This one really far-fetched, huh? Really far-fetched. Not acceptable. Really not acceptable. Example 12. T is the number of hours spent studying, and M is the marks obtained. Okay, so hopefully it is, or rather not hopefully, I think it's really correlated, positively correlated, obviously, not negative. Okay, this is slightly different. Can I have attention? This example, you please put a star there and really understand. Okay, the solution, really, it is one of those questions that is not so standard in a way. Because they gave you the regression line. Because usually we will get some cheap marks by getting the regression line, at least 1-2 marks there. But they don't even give you the cheap marks. But of course, VJC prelim lah. Huh? Cheap marks? No, cannot get the cheap mark because the equation given. How? You are required to find, look, there's a missing value here, P. There's a missing value here, P. You are required to find what is this missing value. Okay, let me explain. Okay, let's not care about all those things first, okay? First, we are required to find the missing value, P. I think you know that how to find summation T, just add all the T up. Therefore, T bar, which is the mean of T, divided by that 80 divided by 8, because number of data points, number of points is 8. Summation M, because you don't know P, you know 500 plus P, so no big deal. This one is this one is 503 plus P. Don't find me lah, oh. Okay. Okay. Can I draw a sketch before I explain the solution, okay? You have found the regression line. Okay, you have found the regression line. Now there is one missing, there is one data here, okay, where, let me see, let me find the value first. T is 11. This one. Oops, sorry. T is 11. You want to find out what is the value of P. And you already know what is the regression line. The regression line is, hang on, the regression line is, why M, sorry. Okay, the regression line is M equals to 0.94 T plus 62.6. Some of you will intuitively tell me, easy one, I just substitute 11 in to this one, I get M. Correct or wrong? Very easy one. How to find missing value? Sub T equals 11 into your regression line, done.
But it's not the point.
Exactly. If you look at my scatter plot here, if you sub in and find what is the value, you're actually finding this value. You're not actually finding this exact data point. Then how? Yeah, good question. Good question. Then how? You must make use of the fact that the regression line passes through T bar, M bar. That is a fact. It must pass through T bar, M bar. So for some value here, this point surely is T bar and bar. The line must surely pass through this point. Now we know what is T bar. We know what is T bar, 10. We find M bar. So it passes through T bar, M bar. We substitute into the regression line, we get this. And you